Welcome to this tutorial on damage stability. Tutorial number 630 focuses on probabilistic damage stability. So what we're going to cover today is really how to use the probabilistic damage stability wizard, and then a little bit on damage stability automation, which is really again talking about the wizard. So this one is really just a focus on how to use the GHS wizard. But first, a quick disclaimer. This presentation is for instruction purposes only. It is not to be used in engineering for construction, and I'm not a representative of Creative Systems. This is unofficial training only based upon my own personal knowledge and experience. For the official training, you can contact Creative Systems at the information at the bottom of your screen. I highly recommend it. It's quite diverse and informative. Okay, so when I talk damage or probabilistic damage stability, the very first thing that you should think of is the DamStab2 Wizard. When these regulations for probabilistic damage stability first came out, there were several people that tried to do it manually. Do not do this manually. The rules were written and designed for using a computer. So there's a lot of iteration in probabilistic damage stability, even more so than normal damage stability analysis. And that's very difficult to do manually, but it's very easy to do with a computer. So do use the DamStab2 Wizard. Now, that DamStab2 Wizard, that does require the advanced features module of GHS, so you need to have that for it to work. But definitely use it. And the other thing I will say is I'm really just going to give you a highlight of how to use the DamStab2 Wizard. The gentlemen at Creative Systems have provided a very useful resource for this, actually. So if you go to ghsport.com under Customer Support, download the Wizard Manual for ProbDam2 Wizard, and that's going to go over the DamStab2 Wizard with examples and details that you can follow along with. So really, download that, read it yourself, and that's the best education you're going to get. So I'm just going to provide an overview of basically what they've already laid out in that manual. Right, so how does probabilistic damage stability work? Well, generally what happens is step one is you calculate what they call the required subdivision index. That's usually called R. Now that's a pretty simple formula, so that one you could almost do by hand. And then what you do is the main effort is you use GHS to calculate the attained subdivision index, A. Now what's so fancy about this one? Well, under deterministic damage stability, people would assign you an assumed extent of damage, and you'd go through with that. Now, it doesn't work that way with probabilistic damage stability. In probabilistic damage stability, you have to consider all multiple combinations of compartment damage, all sorts of combinations. The rules don't tell you which combinations to look at. They allow you to look at all of them, and what you do is you look at whether or not your vessel survives that damage condition or not, but there's a certain probability associated with each one of those combinations. So the really absurd ones, that end up damaging like 5 compartments all at once, they have a very, very low probability. So it doesn't really hurt you too bad if you don't pass that condition. Now, the problem is, though, that you're still applying damage cases and you're still checking stability, but now there are hundreds of damage cases. And like I said, you won't pass all of the cases, and that's okay. And the reason there are hundreds is because it actually is considering divisions in both longitudinal, vertical, and transverse directions. So what I'm going to focus on in this is specifically how to use GHS. I won't cover what the regulations require exactly. Right. The other thing you need to know about probabilistic damage stability is that there are generally 3 separate loading conditions that it's checked for. This is actually written into the regulations, and the terminology shows up in GHS, which is why I'm introducing it here. So you have DS, DL, and DP. DS, which is draft for is the draft service. That's your full load, your service load of your ship. So that's your first loading condition. And that should be at level trim. Now, DL, that's your light load, your draft light. Now, that's not actually your light ship. That's light load. Okay? And that is going to be based upon a calculated trim. So whatever your ship equalizes to at its light load. And DP is your partial load. That's 60% of the way between full load and light load. And that is also at level trim. So here are the three main drafts that you have to look at. And just keep in mind the terminology here, okay? So when you see DS, DL, and DP, just remember that we're talking about loading conditions. And DS is full load, DL is light load, DP is partial load. Okay, so step number 1, start the wizard. The way you're going to do that is first create a new folder for this analysis, because it's going to generate a lot of output files, and it's better to avoid the confusion by just putting it all in one separate folder. Now to start the wizard, you go up to the wizard menu, and then you click under all wizards, and you're going to get this second menu here that pops up. So you'll get this all wizards menu. You want to scroll down until you get this DamStab2. Highlight that and click the run button. Now if you don't have a geometry file loaded already, the very first thing it's going to do is ask you to specify the geometry file. And once that's done, this will start up. You'll see this main control menu appear. So the way this pretty much works is you more or less start at top left and work your way down towards the right. Now the people at Creative Systems have actually provided this really wonderful flowchart, so I give them credit for that, and it's so good that I'm borrowing it to show the process here. So step 1 is you're going to calculate your permeability settings. So permeabilities, what you do is you start by step 1, you click this button right here, the permeability settings, and that gets you to this window here. Now you can actually vary your permeabilities with your loading condition, and you can do that two ways. You can specify it in the wizard, or you can also use a run file for it. The nice way, or the motivation for using a run file, is the repeatability. But if you're doing it in the wizard, that's where this menu kicks in. And the way you do it is you start by specifying the permeability sequence. So notice here we've got the DL, DP, and DS. So those are our drafts, our loading conditions. And you actually specify the permeabilities at each one of those loading conditions. And then you tell it which compartments those permeabilities apply to. Okay, the next thing you do, step 2, was you create critical points. So if I go back here real quick to the flowchart, right, you'll click OK, and it will take you back to this main wizard home. Then you click the purple critical points button, and this lets you define the critical points. So you'll notice this wizard is really set up assuming that you don't have anything defined ahead of time. And it lets you, again, it'll use the critical points from the geometry file. You can also add in a critpoint.cfg run file. That's something you run, or you write yourself, but it actually has to be named critpoint.cfg. Or you can use the wizard to create a special flood points table. So there, when you click the crit points button, these options will appear, and there will be a wizard menu there that you can actually click and type in critical point information. Right. Pardon me. So now you've done that. Now we go on to step 3. And this is the big step. This is where you will spend a lot of your time, is where you create the subdivisions. So remember how I told you that there's all these combinations of compartment flooding that you can consider. Now, GHS is going to calculate that, but what you have to do is tell GHS, it has this geometry of tanks here. You have to tell it how that geometry of tanks lines up into different subdivisions so that GHS knows what probability to assign to each flooding condition. Now, there's a port and starboard, so it's allowing for the fact that these will be an asymmetric hull, basically. And there are 3 different methods that you can use to define your subdivisions. You can do the auto method, which is a big time saver. You can do the div.cfg, which is a run file, or you can use the manual method. So again, you can find lots of information about this in the DamStab2 manual. The auto method, it's a big time saver, but if that's going to work, your tank definitions need to be pretty clearly laid out. You need to have basically a regular grid work pattern in your tank shapes. So you can't have super complex tanks all nested within inside of each other. GHS won't detect the divisions correctly if you do that. So you can also define it manually or through the run file. And you have to understand, you have to understand, when I'm talking divisions here, we're talking longitudinal, transverse, and vertical subdivisions. So all 3 directions. And that layering is really what you're defining. Is, you might have a first layer of tanks that's closest to your side shell, and then another layer of tanks inside. So that's a second transverse subdivision. And that layering is really what you need to be careful about defining, because that affects how GHS calculates the probability of each tank being damaged. Okay, so this right here is the example of the subdivisions menu. And one of the important things if you're doing it manually is that you have to recognize that GHS knows that the compartments are linked. Okay, so it knows that the aft bulkhead of tank number 1 is the same thing as the forward bulkhead of tank number 2. So you only have to specify forward bulkheads. It always knows that, hey, this forward end is the same as the aft end of this tank. So that's how that works. And what you're doing here is you're specifying positions of the subdivisions. And then GHS will include the appropriate tanks. Now, once you also specify these subdivisions, you can also define the wings and the decks. So that's, what you're defining here is longitudinal subdivision. And then you have more information as well under the More button or through Define Wings and Define Decks. Both of those will let you define your transverse and your vertical subdivisions. I will definitely say read up the DamStab2 Wizard manual on how to do this. Okay, so you've spent considerable amount of time doing that. Now we're on to step 4. So you click your button for your loading condition setup. There are 3 methods for setting up loading conditions. Number 1, you can just type in the total weight. Number 2 is you can create a run file that adds all of the individual weights and sets the tank loads and all of that. Or number 3, you can use the load editor, which is a interactive GUI that GHS has for specifying loads. Now, you're going to set up that load condition. You're going to set up all of your weights and all of your items like that. But then you have to tell GHS, okay, I've created this load condition. Which one of the 3 regulatory drafts does it apply to? Is it the light load, the partial load, or the service load draft? And then you save the load information under that condition itself. So you'll do that for each one of those load conditions, or for only one. It depends on what type of analysis you're doing. GHS is okay if you define just one, that's okay. But for the full assessment, you actually do need to define all 3. That's a regulatory requirement. Okay, so load conditions. This is the easy way to do it. So you can do this right here, which is just typing in your all up weight. You put in a VCG, and then you can put in draft and trim, or weight and LCG, and GHS will calculate the load in the correct position. The reason you need to do the VCG in there is so that it can correctly calculate the trim, or the moment that would result from that trim. So that has to do with its stability. Now, if you don't like that option, you don't have to do it. What you can do is click on these buttons down here to either add loads using your own run file, in which case it'll ask you to specify the run file, or you can add loads using the load editor. So that all works. And once you've set all of this up, you have to click your radio buttons down here to tell it which condition does it apply to. Once that's all done, you click save this condition and hit OK to finish. Okay, you've made quite a lot of progress by this point. You've set up your model pretty well, and now what you have to do is you're actually ready to run. So what you have to do is pick your stability criteria. So this is the probabilistic cargo, passenger, these are all the possibilities. And those refer to actual regulations. So the requirements of the regulations, the stability criteria, are programmed in. What they're doing there is they are calculating what your required subdivision index is. And then you're going to pick your load conditions. So that's up here where you're either going to use your current load condition, or you're going to use all of the load conditions that you've defined. And that's those three separate load conditions. So once you pick all of that, you click your run button. And you're going to get an output that looks like this. It is a report output, so you can easily refer to it at a later date. And it's very nicely formatted. So to break this down, basically what we have here is on the left, this is all the possible subdivisions that are being considered. This middle group right here is the result of the calculations. So that's the really important stuff. And then this is just some information provided about each one of the damage conditions. So the probability is the first thing. That's what GHS is calculated because you've totaled all the information about the subdivisions. This is the survival probability. So that's either going to be 1 or 0. Either it survives or it doesn't for each one of those damage cases. And once you do all the math, again, this math is defined by the regulations, and GHS has it already built in. So once you do all the math, you get this attained index. And so you're getting an attained index for every single damage scenario. And what you do is you add all of that up. You add up all of your attained indexes, and that gets to your total at the bottom. So we have attained index for this condition of 1. The required index, this was set by your stability criteria, is 0.492. And that's what you want to see. So A must always be greater than R. That's the requirement for probabilistic damage stability. And the way it works is, this was just for one draft. You can also do it for multiple drafts, and it will actually do a weighted average based upon the regulatory requirements for how to do that weighted average. Again, GHS automatically calculates this weighted average. Okay, so time to have a bit of fun. What I would say is homework 631, complete the probabilistic damage stability analysis. Use the barge that's included. Really, I would even just say, the best homework that you could do is open up the DamStab2 manual, look at the manual, run through the exercises they have in there. But you can also try it with the barge as well. So start with the manual and then graduate up to the barge. Okay, well, thank you very much for watching. I hope you have found this video informative. You can find the homework files the manual and the other tutorials like this online at dmsonline.us. Thanks very much.
Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button and I will make more videos for you.